We are now getting to lesson 6 of this chapter, the chapter on enzymology, or simply enzymes. We are talking about effects of temperature, pH, substrate concentration, enzyme concentration. In the previous lesson, which is lesson 5, we were just showing how temperature affects enzyme activities. That may not be too different from the one we are going to treat now, which is the second factor that affects enzyme activities. So, this lesson, which is lesson 6, shall be dealing with the pH, which is the second factor that affects enzyme activity. So pH is so important because our bodies are made up of fluids. These fluids must at times be at a particular pH that is conducive for the body's activity to take place, because if your blood becomes too acidic, it is a problem. If your blood becomes too alkalinic, it is a problem. So the pH must always be kept constant depending on the different regions of the body. But here we are talking about the pH as a factor that can affect enzyme activities. So we should not get lost here, because we know that there are some enzymes that act with respect to the type of pH in which they find themselves in the pH range or scale. So, when we talk of pH, we have to bring into mind hydrogen ion concentration. The hydrogen ion concentration, or the concentration of hydrogen ions, should give you an idea of the pH of that particular medium. Enzymes function most effectively over a particular pH range at a constant temperature. This is important. Enzymes function most effectively over a particular pH range at a constant temperature. Because if the temperature is not constant, it will not affect exactly the enzyme activity. If you are trying to analyze the effect of the pH, you must keep the temperature constant. They are mostly, that is enzymes, they are mostly effective in only a narrow range. They are mostly effective only in a narrow range, because ranges that are wide will bring adverse reactions, will affect the reaction of the enzyme. So it is mostly effective in only narrow, in a narrow range, in a narrow pH range. The optimal pH is the pH at which the maximum rate of reaction pH is the pH at which the maximum reaction occurs. You can understand this when we also talked about the optimum temperature. That is why I said at the beginning that these two can be put together to understand them better. When the pH is changed above or below the optimum value, when the pH is changed above or below the optimum value, the rate of enzyme activity reduces. This leads to changes in the charges of the enzyme and its substrate. This leads to changes in the charges of the enzyme and its substrate. When this then happens, it affects the binding of the substrate to the active site of the enzyme. Because when ionic changes occur, is that clear? Some now structural changes occur at the level of the active site, making it impossible for the substrate to bind now to the active site, thereby now slowing or maybe stopping the reaction. Extreme pH levels will produce denaturation. Extreme pH levels will produce denaturation. We should understand this, because if we do not understand the pH scale, we may not be able to understand what we are talking about. It is imperative for us to know that on the pH scale, you have from 0 to about 7, it is acidic. At 7, it is neutral, and 7 and above, that is 7 to 14, it is alkalinic or basic. If you don't understand this, you will not understand what we are talking about, because that is the pH scale. 0 to about 7 is acidic. At 7, it is neutral, and 7 to 14, it is basic or alkalinic. That is why we are saying that extreme pH levels will produce denaturation, because if the medium becomes too acidic, it will denature the enzyme. If it becomes too alkalinic, it will denature the enzyme. Therefore, changes in pH from optimum pH brings about the changes in the ionic charge of the acidic and basic group, and therefore break the hydrogen and ionic bonds that help to maintain the specific shape of the enzyme, and the enzyme becomes denatured. So what happens precisely is that when you get to extreme pH levels, that is acidic and basic, more acidic and more basic, it means that you have gone above the optimum temperature at which the enzyme acts. You have gone above the optimum pH at which the enzyme acts best. And this brings changes in ionic charges of the acidic and basic groups, and this now will lead to the destruction or the breaking of the ionic bonds that help to maintain the shape or the specific shape of the enzyme. And when this is destroyed, when these bonds are destroyed, the active site now loses its shape, and this brings about the denaturation of the enzyme. The substrate in this case no longer fits readily into the active site of the enzyme. The substrate in this case no longer fits readily into the active site of the enzyme, and the enzyme normally becomes ineffective. Ineffective in that it cannot catalyze any reaction at this stage where its ionic bonds have been altered or broken. The enzyme is rendered inactive. Digestive enzymes in the stomach. Digestive enzymes in the stomach work best under acidic conditions, whereas those in the small intestine work best in alkalinic conditions. This is understood because we all know that in digestion, at the level of the stomach, hydrochloric acid is secreted. And if hydrochloric acid is secreted in the stomach, it therefore means that at that particular point, the hydrogen ions are greater in their numbers in the stomach, thereby increasing the acidic nature content of the stomach. Therefore, enzymes that are produced in the stomach will normally act in that acidic condition. And that's why in the stomach, the enzymes that take place there, the enzymes that react there, work under that particular acidic condition because the acid is produced, which is hydrochloric acid, to ease that process of digestion. But in the small intestine, the medium is no longer acidic. The medium is basic. Therefore, only enzymes that act in alkalinic conditions will normally go about carrying out their activities in the small intestine. When we look at this graph, it now gives us a picture on how the pH affects enzyme activity. You now see that at 7, which is the neutral point of the pH scale, the enzyme graph is at its peak. And below 7, that is from 4 to 6, and 8 and 9, the enzyme is just at its normal activities. Now, when you look at the next diagram, which is some kind of putting together temperature effect and pH effect, you may see that there is a similarity. But in this case, there is a peak where you have the optimum temperature and where you have the optimum pH. And these are the areas where enzymes act best. The diagram below is just similar to the second diagram which I just explained there, showing us the optimum pH and the rate of reaction of enzyme at the level of the pH. You now see that the graph starts increasing. As the pH is increasing, gets to the optimum levels and drops or falls as the pH goes above the optimum pH. This diagram is also important because it shows us the optimal temperature of two enzymes. The optimal temperature of two enzymes. So here above, you have the optimal temperature for a typical human enzyme. and the optimal temperature for an enzyme of thermophilic bacteria. You see the one in black and the one in red. And below the first one, you have the optimal pH for pepsin. That is an enzyme that acts best in acidic medium for the first black graph. The second graph, which is red, is the optimal pH for trypsin, which is an intestinal enzyme. This is an enzyme that normally will act in the small intestine where the pH is alkalinic from pH scale that you have here. You now see that for the black graph, which is found between 0 and 4, you have the enzyme pepsin, which is an acidic enzyme, or which is an enzyme that acts best in an acidic medium. Now, between 6 and 10, that shows us that this enzyme trypsin acts best in an alkalinic or basic medium, and this is normally in the small intestine. The next diagram is just a summary of the different enzymes and the regions at which they act best on the pH scale. Looking at the enzyme pepsin acts best in extreme acidic pH between 1 to 3. Pepsin is at its peak. You have salivary amylase, which is almost neutral, acting in an almost neutral pH level, which is slightly acidic and slightly alkalinic. Then you have the enzyme phosphatase, which is a purely alkalinic enzyme that acts best at extreme pH or at high pH. So this is just to tell us that digestive enzyme or some enzyme act best at particular pH levels or at a particular range of pH. But I want you to understand here that pepsin, which is an acidic enzyme, cannot act in the region of 8 to 10 because that is a basic region of the pH scale. Likewise, phosphatase cannot act best where pepsin is acting because pepsin is an acidic enzyme while phosphatase is an alkalinic enzyme. So you have to understand it this way with all these graphs. And these graphs are there to make you understand clearly the effect of pH on enzyme. Thank you for your kind attention.